Welcome to Ymt218 Object-Oriented Programming, and this is chapter 10. We will be discussing just the introduction of classes and object-oriented programming. So what we have explained so far in this semester about object-oriented was just the introduction to reach to the point of the object-oriented. We spoke about a little bit, actually not much, about objects and their methods. However, the real object-oriented programming starts here, and that's why you should pay attention to whatever is coming throughout these chapters. Okay, so we'll be going through one main topic, procedural and object-oriented programming, the difference between these two. Then we will just elaborate the object-oriented programming itself. We will speak about objects, the encapsulation, the data hiding, and object reusability. So we will speak about those as an introduction. We will not just go through how to create classes, how to use classes, how to instantiate classes. We will keep that part to the next part. So procedural oriented, mainly what we have studied so far in this course is procedural oriented or procedural programming. We rely on functions like the way we used to create main, def display, for example, whatever function that we create. So we create these functions, we use their definition and we give them a name, and we create them for a certain reason, for a procedure. So what does it mean? It means that we process something using these functions or procedures. We process what? Data, and this is what we usually do. Either we process some data without any return from a function, or we receive data as an argument or a parameter to the function, and then we process it. So if we have some certain argument to be received, we apply some operation to it or on it, and then we get the output, or we pass it to another procedure. So the idea is we have a procedure set or defined by a function, and we receive data. We apply the functionality to this data, or the procedure to the data that we are interested in, and then we display or return the output or the outcome, or we pass it to another procedure for some certain reason. Now the idea here is our procedure is separate. We apply the operations to separate data. They are not all together. So the data and the procedure, or the operation to this data, or to the data used in procedure, are separate. They are not mixed up, and they do not belong usually to one unity or to one object. So this is the main idea. In that case, what we need to do is we need to focus on the procedure itself, how the procedure is actually operating. We don't care about the data. Just the only thing that we need to do is how the data processed, or the essence of the data processed. So how we can send it, what kind of data we are allowed to send, or what kind of process that guarantees the data to be fit or suitable, or it matches the type of my procedure mechanism. So in that case, this is the main idea. We create procedures, each procedure for doing one or two or three operations or a bunch of operations on certain data, and this data is separate. Okay. Now let's think about object-oriented. Object-oriented, we don't focus on procedures. Rather, we focus on actually creating objects. Instead of creating procedures, just operations to run on separate data, no. We create an object. So what do we mean by objects? Objects in basic sense in object-oriented programming means an entity. Entity that contains actually two main things. First, data, and second, procedures applied to the data. Or you can say functions or methods applied to the data. So this is the idea. So we have data, and this data, or the type of data that we have in an object, is usually describing the attributes of the object. So if you have an object, you want to describe it, that's the data of the object itself. So the description, or what we call the attribute. So these attributes are set as the data of the object, and what we can do with these attributes, we call them, instead of a procedure, we call them, in this case, methods applied to the data. Now think of an object. I'll give another clear example later on, but think of it as a student. Student is an object. We can think of it as an object. Okay, don't think he's a human being. Just think of it as an object. If you think about some data to describe this object, what do you think? How about name? Well, this is an attribute, right? How about the department of the student? Maybe the university, maybe nationality. All these are attributes. Okay, how about the methods that the object, or that can be applied to the data? Maybe displaying name can be a method. For example, maybe accessing, let's say, an automation system using ID or whatever. That's also a method. Maybe retrieving some information, that could be a method. So there are many types of methods can be applied to the object depending on the type of the object and the data available in this object. Okay, so what's the idea? Why do we need to have it? Since we have procedural oriented, we can create our procedures, keep the data the way it is, we pass it from one procedure to another, we get our output, so we don't have to bother with object-oriented. What's the point? Why do we need to have such a scenario in programming? First of all, encapsulation. Encapsulation means what? Instead of having separate data and separately data and procedure, how about if we combine them together and then we create what we call object? I just explained about the entity where we have data and procedures. So we encapsulate these two, and then we can deal with these two as an object. It sounds more convenient for sure, and there's another reason. The second reason, let me explain before the second reason. Good, we have this visualizing illustration. Look at this object. We have the data attributes, the what we have as a characteristic of the object. So these are the characteristics of the object, or the object that we are discussing now. And then we have the methods applied or operated on the available data. Okay. Now, the second reason for having this paradigm or the scenario in programming object-oriented is data hiding. Now think about this. Data attributes here, a programmer or whoever is using the program may need to see and create, right? But how about a user? What's the business of a user dealing with data inside an object, or actually private data somewhere? The user in this case has no business to reach to that type of private section. So we can hide this data or the whole section itself and keep the access through some methods. So from outside of this object, we keep the access restricted to methods that they can access to the private data, and this is what we call data hiding. And it's extremely important software and programming and software development. So it's extremely important. Okay, you may say, okay, what will happen? What's the point if someone is accessing to the data? What will happen? First of all, maybe there is a privacy concern. It could be. The second thing, how about the manipulation or corruption of data? If you're going to lose your data, that means your program most likely will not produce the outcomes expected from it. Okay, so that's the point. The third advantage, or actually reason for having object-oriented programming, is the reusability. Once we create an object where we have our data and the procedures applied to or on the data or the private data of the object, then we can reuse this object. There is nothing stopping you from reusing it. But if you want to reuse a procedure, then you have to create a module. If you remember, we created a module, and then we got that module and we use its own methods. But object is more convenient. We can create it and use it as easy as it is. It's not just like any complicated thing that we need to deal with. You just need to know its attributes so that you know what type of operations you will be expecting, and then you will need to know the operations or the methods applied to the data, and that's it. In that case, you can just use the object available in your own programming, and we will see how we can create our own and use available also objects, instantiated objects from classes. Because usually we don't have objects with no classes. We have to create their own classes, or their classes should be created so that we can instantiate them and use them, okay, in most cases. All right, now look at the idea of data hiding. So now look, now we have data attributes or private data, and then we have these methods which usually are set to public. Sometimes we have private methods for some reason. I'll explain about that also. And then we have like code and outside, you can say, outside whatever. Maybe part of a code or an actor in brief, someone who's trying to access to the private data. You cannot access directly, you have to access through some methods, and these methods will decide whether your access is eligible or not. In that case, you protect your data from any intended or unintended, you can say, corruption or manipulation, okay? Now, let's just take a simple example before we end this introduction part. What can we give as an example of a class, of an object? I mentioned earlier about student. That could be an example, yes, but let's give a better example, an example that you guys can visualize with no problem. Now think about the clock that we have at home. Well, recently people started giving up clocks because the use of smartphones and stuff like that. But still, maybe most of houses actually have some clocks. So what do you expect to have from a clock? Time. So this is the main attribute. So, well, in order for me to read the time or to get the time, I will need to learn or to know the hours, the minutes, and the seconds. And in that case, I'll learn the time. So the private attributes here of a clock as an object can be hours, or the hand of hours, or maybe if it is digital, then hours, minutes, and seconds. And these should be kept private. If you want access to them, you have to access through methods, okay? And as I said, these attributes, usually we restrict them to private. And we will see how we can create private attributes or data or even methods in Python soon enough. Then we have public methods. Now imagine what kind of methods do we need to apply, or operations or procedures do we need to have, or should we usually have actually in an object as a clock? Think about setting the time. Think about setting up the alarm, okay? Maybe you need to set up the time, maybe you need to set up the alarm. These are two main functionalities, and if they are not private, you as a person, you cannot get to them. So you cannot set up the time. Let's say you want to, your clock is just bought, its time is not accurate, you need to fix it, or you just changed the batteries, or for some reason you need to set up the time. So if you don't have that functionality, that procedure, how will you set it up? If you want to set up the alarm for some, you can say waking up or setting up a timing or appointment or whatever. So in that case, you need to have a method in order for you, or in order to allow you to have some access to internal functionality to set up the alarm. So now, how can we do such a scenario? Maybe by a few buttons that we can push, we can set up the time, or maybe some gear we can move in order for us to set up the alarm or set up the time. But how that happens internally, then we have private methods. We do our part from outside for setting up the time or setting up the alarm. How the alarm, how the time itself changes, like how the hours change, how the minutes change, how the seconds change. We have private methods inside the object we don't interfere with. They run privately inside the scope of the object itself. Think about the sound of the alarm. When the alarm clicks in or kicks in, what happens? There should be a sound. You don't do that. It's automatically coming through a private method. And this kind of example can be generalized for any object in our life or any object in programming. And that's how you should imagine an object. So from where this object is coming, how can we have it? This will be the topic of the next session. Until then, have a good time. Goodbye.